Hello everyone. In the series of 8051, today let's discuss about interfacing of stepper motor with the 8051. So in the last session we have seen that interfacing of DC motor. Let us see the difference between DC motor and stepper motor. So usually stepper motors are rotating continuously, whereas stepper motor, the rotation of a stepper motor has a step by step. That is the major difference. Stepper motors are used to achieve exact position and to gain the exact angle we can use stepper motors. So for industrial standards like a pick and place robot and arm, for that applications we can use stepper motors. So here we can calculate the step angle. Based on the step angle calculation, exactly we can achieve the required angle. So let us see what is stepper motor. So I'm taking 4 winding stepper motor. This is the shaft of the stepper motor. You can find 4 windings are there, named as A bar, B bar, and the center tapped winding is called common terminal. So we have a 2 common windings, A common and B common. So now here you can see the definition for the stepper motor. It is an electromechanical device which converts electrical pulses into discrete mechanical movements. That means to the windings, here we have a 4 windings. To the 4 windings in a one sequence of pattern, by applying the discrete clock pulses, we can rotate the stepper motor in clockwise direction as well as anti-clockwise direction. Here you can see we have 4 windings is known as A bar, B bar. So in the hardware connection which was connected to 2.3, port 2.2, port 2.1 and port 2.0. So now to the windings of stepper motor, by applying the clock pulses in this pattern we can rotate the stepper motor in clockwise as well as clockwise. So applying the clock pulses in two ways. We can apply the pulses in two ways. So one method is called full step method. So in the full step method, in this sequence, both the coils are energized at the same time and motor shaft starts to rotate. So we have a coils in the full step method. At a time we are giving the clock pulse or say discrete values to the two coils or two windings, so that at a time two windings are gets charged, right now. So here uh, in the full step, actually in the full step we can, for the one moment we can get 90 degrees of angle. So to complete the one revolution it requires to complete the 360 degrees. Here for each discrete value it is taking 90 degrees. So in a one single movement it will cover 90 degrees. For the second discrete value it may get one more 90 degrees, 90 plus 90 180 degrees. For the third value it will achieve 180 plus 90 270 degrees. After that for the fourth clock pulse it will achieve 360 degrees. So to complete the one revolution we have to apply 4 discrete values to the windings. So in the full step, at a time two coils are gets energized, so that it will take 90 degrees of movement. Okay, and second method is called off step. So in this one, if you see the sequence of how the coils are energized, in that sequence, first one coil gets energized and then two coils are energized. Again in the next sequence one coil gets energized and then two coils. In that pattern you are applying the discrete pulses. See here. So here actually for every discrete clock pulse applies, it takes 45 degrees of angle. In a full step, it will cover 90 degrees. For the half step, for every movement, it is taking 45 degrees of movement. So to complete one revolution, here we have to apply 8 different sequence pulses, sequence values, discrete values. Right now, so as per this table, by applying 8 discrete values, we can rotate the stepper motor shaft for 45 degrees, 45 degrees. Okay, now let us see hardware section. This is the connection, and here also, like how you are taking the driver for the DC motor, here also we have to take one extra driver to drive the stepper motor. So it is also requires high current and high voltage. Okay, so this is the driver name. You can notice here ULN2003A internally, which consists of Darlington transistor pair. To that pair, you are connecting stepper motor windings. So here mention the coil name as A bar, and B bar. Middle of the windings are common terminals. So these are commonly connected to VCC. So it is also 16 pin IC. Sorry, it is a 18 pin IC. So A7 plus 7, 14 pin IC. No, sorry. It is the 16th pin IC. So 1 to 16 pins are there. Out of that, 9th pin is the common. Have to connect it to the VCC. Okay, so we have 4 windings, so that you are connecting for which are the driver inputs 1B, 2B, 3B, 4B, which are the inputs. So these inputs are connected to the microcontroller IO lines, and the respective pins are connected to stepper motor windings 1C, 2C, 3C, 4C, and remaining input side 5, 6, 7, which are unused at output side 5C, 6C, 7C, which are also unused. Simply you are taking 4 inputs, and respective outputs are connected to the stepper motor windings. So when you are picking the components, one is our controller AT89C51. Actually already I have taken these components. Okay, and second component is called motor driver. The driver name is ULN 2003 A. It is the motor driver name. High voltage, high current, Darlington transistor array. And second one is the motor. Search with the stepper motor. You have three motors there. So you have to choose animated unipolar stepper motor. Select these three components and connect as per this diagram. So now our role is, to the port 2 we have to apply discrete values in this pattern. Okay, so now first let us see full step. In the full step, at a time, two clock pulses or two windings are energized. So yes, we are giving the clock pulses in one pattern, one sequence of pattern. So 1100, its equivalent hex value is the C. Now directly I am sending move port 2 comma hash 0CH. So after sending every winding, after sending every discrete value, we should provide some time delay, a call delay. So delay is important here. So in the previous classes, how to I told you that how sub program delay is working. So this is the subprogram for delay. So after 0C, what is next value in the table? 06. Equal delay. Next value. So in the same pattern, we can send remaining values also. To avoid the time, simply I'm copy and paste. Next value is the 03 and next value 09. That's it. Copy and come to Keel Microvision, paste. Already have created the project here. Compile, zero errors, zero warnings. After that, create the X file, output, enable check mark on the create X file, give the X file name, okay, and execute one more time. Now your X file was generated. Come to Proteus, double click. In the respective path, you can find X file. Okay, now here you can see the step angle. Run the circuit. Yeah, 90 degrees, 180 degrees, then 270, then 360. After that, you have stopped the motor. Again, if you want to rotate the same value, you can give like a short jump to main program. So continuously I want to run this motor, short jump to main. Again after 360 degrees, come to again 0 degrees. So continuously it will rotates. Initially angle is 0 degrees, then 0 to 90, then 90 to 180, 270, 360, again 360 to 360 or 0. Both are same actually. Okay. Now so this is the table. In case for the same table, if you apply the discrete values in the reverse pattern, so that means from bottom to top. So previously we have applied values as C639 top to bottom. Then stepper motor is taking clockwise direction. In case if you are applying the values in the reverse order, that means 09 number, then 0C, 03, 06, 0C, then same stepper motor starts to rotate in the anti-clockwise direction. Let's check out that. 936, first value 09, 03, 06, and then 0C. Now if you apply the discrete values in this pattern, now stepper motor will rotate in anti-clockwise direction, means reverse direction. So initially it shows 0 degrees, then it starts to rotate in the anti-clockwise, minus 90, yes, minus 90, minus 180, minus 270, and minus 360 or 0. Okay, so now it is rotating in the anti-clockwise direction. Okay, short jump to main. See, one, see, 1, 2, 3, 4. Totally 8 lines are taken to rotate the stepper motor. Instead of that, I have one more logic. Second method. So instead of all these 8 instructions, we will do one thing. Move a comma, what is initial value? 0c. Then I'm taking 0cc. You tell me why I'm taking 0cc. Okay. After that, I'm sending this values to the port 2, and later provide the a call delay. Rotate left. Okay. Then short jump. Go. It is a second approach. So instead of 8 lines, you can approach this method also. Okay. So I will write the same code in the Keel software. Now I'm removing all this. Move a comma hash 0cc h. Then send to port A, port 2. Provide some time delay. After that, rotate left and short jump to back. So initial value CC, then values are rotate to the left. Yeah, plus 90 degrees. Wait a minute. Short jump to 9. Sorry, which are the rotating right actually, as per the table. So values are shifted to the right. So we should write instead of left, should just to right, rotate right. Now let's execute 90 degrees. What's happening? Problem is destination path is the destination to move port to comma A. Previously given at the starting line, that was the problem. Okay, move port to. This is the target. Short jump main. So main has to be right here. Now compile. Check out. Plus 90, plus 190, plus 270, then 360 degrees. Okay. So as per the table you take it. In case if you apply clock process from bottom to top, so initial bottom value is the 9, then it is rotating to the left one time. Initial value 90, so I'm taking 99. So in the comment section, you can tell why I'm taking instead of 9, I'm taking 99. Okay, then take rotate left. Now compile the code. Minus 90, minus 190, minus 270, then minus 360 degrees. Same logic, approach is different. That's it. Okay. This is the full step, and in the off step you are sending discrete values to the one pulse, one winding, later sending discrete values to the two windings at a time. See there, two windings, then one winding, again two windings, then one winding, two windings followed by one winding. So by sending the discrete values in this pattern, stepper motor is taking 45 degrees of movement. Let's check this. Same code. So instead of these values, you have to write the tabular values. Let's check this. So what is the first value? First value is the 9, 09H, a call delay. Then move O2 comma hash 08H, a call delay. Next value is C4, 62, let's see, 04, 06, 02. Next value 03, and eighth value 11. Sorry, last value is the 1 number. Okay, so this is the X table. You can see this column. So as per this, I am sending the discrete values 9, 8, C4, 6231. Okay, right. I can short jump to main. Now, when you are sending the discrete values in this pattern, it starts to rotate in clockwise direction, but the step angle is 45 degrees. You can observe here. So taking with the 45 degrees, then 90, 135, 180. Okay. Now it is taking the values in taking the movement with the 45 degrees angle. 350, then 360. Again, initial is 0, 0 to 45. You can observe this. So this is taking the clockwise direction. In case to rotate the stepper motor uh, in the anti-clockwise direction, from this table, just apply the discrete values from bottom to top. 1 first, then 3, 2, 6, 4 like this. By applying the values in this pattern, it starts to rotate in anti-clockwise direction. Okay, thank you. So if you have any doubts, you can ask me in the comment section. I will answer you. Thank you.